In this video, I am going to explain a very important concept. It is called formal charge. Formal charge, we may write down FC. Actually, formal means anything which is official, which have some weightage. Certain conditions are fixed or certain parameters are standard. That is said to be formal. So, similarly, the charge. Actually, formal charge is a way to know the best stability of certain species, best stability of certain species or some molecule or some ion. So first, see, it is defined as the charge carried by an atom present in an ion or species. It can be an ion or it can be a molecule as well. So it is the statement of formal charge. Now, how we can calculate? So, formal charge on an atom. Formal charge on an atom, it is equal to, it is rather mathematical calculation, it is equal to number of valence electrons in the atom. It is number of valence electrons in the atom. So, number of valence electrons in the atom, it is in the molecular ion minus number of non-bonded electrons on the atom. Non-bonded electrons means the electrons which do not take part in the formation of bond or which are lone pair electrons minus half of the bonded electrons. So this is the formula to find out the formal charge. So once again, formal charge on an atom in an ion or molecule is equal to number of valence electrons. Number of valence electrons, it can be find out with the help of electronic configuration. So that is there, minus number of non-bonded or lone pair electrons minus half of the bonded electrons. So this is there to find out this. Or simply we can write down in brief, Fc, it is equal to valence electrons minus non-bonded electrons minus half of the bonded electrons. This is very simple point. Valence electrons, non-bonded electrons and bonded electrons. But the point is, why we should study the formal charge? Actually, just I have said in the starting or beginning that it is a way to have some idea about the geometry of molecules or structure of molecules. Geometry or structure of molecules, they are indicated. And so, we will see the importance. What is the importance? So, importance is only one. It helps in a study of the stability of the concerned species. Stability of concerned species. Then point is how we come to know that which is stable. Actually now the charges are responsible. Charges are responsible for it. For this the calculation means the calculation or finding of formal charge helps in the assessment of stability. Helps in assessment of stability. How? Similar charges causes repulsion. This this thing. There is repulsion in similar charges and attraction between different charges. If the charges are different, then there is a repulsion and attraction. So, using repulsion attraction. Actually, you know about the octet rule. So, octet rule tells about the stability, but octet rule has not said anything about some structure of molecules. As a result, this was used. So, this complements the octet rule. Fc formal charge complements the octet rule. Now, we'll see how to find out. See here I have drawn ozone molecule. Ozone molecule means O3. O3 is made up of 3 oxygen atoms. And see, here just I have drawn. This is 1, this is 2, and this is 3. And simply oxygen, atomic number 8, electronic configuration is 2 and 6. So, see here, the octet has been completed, the octet is complete, and here 2 electrons are present and these dotted electrons, they are non-bonded, means they do not have participated in the bonding. So, this is it. Now, coming to 6 electrons, so 2 electrons here children, 2 electrons here, and 4 electrons here, and so we can have like this. So, first we see charge on atom 1. Charge on atom 1 means the formal charge. What is the formal charge on atom 1? So, first valence electrons. So, valence electrons is equal to 6. 6 valence electrons from this. Then non-bonded electrons. Non-bonded electrons means we do not take part in the bonding. So, 6 minus 2. Then half. Then bonded electrons. So, bonded electrons you have to find out. So, one bond is made up of 2 electrons. So, 2 electrons here and this double bond means 4 electrons here. So, 4. So, it will be minus 6. And as a result, we can have the calculation. And so, as a result, the formal charge will be 1. This will be 1. Now, coming to charge on atom 2. This atom 2, similarly same condition. So 6, 6 valence electrons, they are 6. Then coming to non-bonded electrons, so 1, 2, 3 and 4. 4 minus half. And what about this? What about the bonded electrons? So the bonded electrons, they are here 2 bonds. 2 bonds means 4 electrons. So it will be here 4. And as a result, you can find out, and here it will be, 0. Now coming to charge on atom 3. So again 6 valence electrons equal to 6. Then coming to non-bonded non-electron electron 2 2 4 2 6 minus half. And what about the bonded electrons? Bonded electrons, they are 2 because there is only one bond. So it is equal to 2. And as a result, on solving, we have this plus. And as a result, here we write down. So it will be plus 1, here it will be 0, and here it will be this 1 will be equal to this plus 1, here it will be also plus 1, and here atom 2 will be equal to 0. So, it will have an idea. Actually, this formal charge indicates an idea. See, the positive charge and the positive charge. This 1 on plus 1, this 2, here it will be 0, and this 3 it will be plus 1. So here the point is that this charge and this charge, they are same. Here it is neutral. This atom, as a result of this, it will have its own identity. It will have its own character. Similarly, also this gives an idea. Now you will see in this video very important point: ionic bond or electrovalent bond. Ionic bond is also called as electrovalent. So ionic bond or electrovalent bond. So as the name indicates, ionic or electron, it means there are charges on the concerned species. So bond which is formed by the transfer of electrons is called as ionic bond. So a bond formed by the transfer of electrons. This is very simple. Transfer of electrons takes place between the concerned atoms, and as a result, there is the gain of octet, or octet is completed, and as a result, charges are developed. There is the development of charges, and so there is the formation of molecules as per this. See, example, formation of sodium chloride, molecule. We'll see how sodium chloride molecule is formed. So actually, children, in all the cases, there is the loss or gain of electrons. So first, see sodium, atomic number 11, configuration 281. Chlorine, atomic number 17, 287. This is our basic idea. This we know. Now, oxidation reduction. So first, sodium, atomic number 11, 281. Now, sodium is a metal. What is a metal? Metals are electropositive in nature. So, sodium atom will acquire positive charge by the loss of electron, and here the atomic number becomes equal to 10. And in this condition, it has become equal to neon, or we say sodium ion or sodium cation has acquired the electronic configuration equal to neon, and its octet is completed. Here we say the octet is complete. Now, this chlorine atom 17, 287. So here 7 electrons in outermost orbit, and as a result, chlorine is highly electronegative. Why? Because it has 7 electrons in outermost orbit, and so it will gain the electron. This electron lost by sodium. And as a result, there is formation of chloride ions. And this oxidation and this is reduction. Here it will be 18, 2, 8 and 8. And this will become equal to argon, noble gas. All the concerned atoms, they acquire nearest noble gas configuration. So here we say octet is complete. Here octet is complete, here octet is complete. So by completing the octet, this sodium, which is highly reactive, it has become stable by the loss of electron. Similarly, this chlorine has gained an electron and it has formed the chloride ion. So again its octet is complete. Now, as the octet is complete in both the conditions, so here we can write down this electron, it has been consumed here, and so we say Na plus Cl minus will form NaCl, and this is the formation of ionic bond or electrovalent bond. Now we'll see the properties. So first property is that they are water soluble. Ionic compounds are water soluble. Why? Because water has polar nature. Water is polar nature. Polar nature means if you draw a water molecule, so here there will be the structure like this, and here hydrogen has delta positive charge and oxygen has delta negative charge, and this is the polar nature. Polar means poles, opposite charges, positive and negative charge. So the sodium ion here, it has positive chloride ion and negative charge. So what happens? The chloride ions, they are attracted by the hydrogen, and sodium ions, they are attracted by the oxygen. As a result, this bond becomes weak in water. Bond becomes weak in water. This is very simple point. When we add any ionic compound into water, due to polar nature of water molecule, the force of attraction or the bond becomes weak, and as a result such compounds are water soluble. So thus they are water soluble. Second, they have high melting and boiling points. Their melting boiling points are high. Why? It is because ionic compounds are made up of oppositely charged ions, and due to oppositely charged ions, there is a strong force of attraction. So, due to strong force of attraction, what happens? When the force of attraction here, it is strong. So, naturally, this bond has to be, broken in order to melt or boil. So, this is there. High melting boiling point means the strong force of attraction between the ions, and so large amount of energy is required. Third is, they are able to conduct current in molten state. Molten state means when they are heated to melt. Molten state and aqueous state. Aqueous state means solution. Why? Because ions are, in this condition, ions are freely available. When any salt is heated or any salt is dissolved in water, the ions are easily available, and as a result, they are able to act as conductor. Now, other point that they are having definite 3D arrangement. They have definite 3D arrangement, or simply they have lattice arrangement. Lattice arrangement means the perfect three-dimensional arrangement. perfect three-dimensional arrangement, and so as a result, the ionic compounds have that property. See how. Now, lattice is like this. Here I draw this type of structure, and here there is the, this is the perfect arrangement of the particles, and there is the symmetry. See how the ionic compounds are having symmetrical arrangement, and here there is the this is lattice. See the 3D structure, and if you have index like this is the chloride ion, and this is the sodium ion. So if you draw here chloride ion, so there will be the sodium ion, here chloride, here sodium, here sodium, here sodium, here chloride, here chloride. So just opposite case has to be drawn here. Opposite case. So this is nothing, but this is called as the lattice, or which is called as three-dimensional arrangement. So we draw like this, and how they appear completely. And so this is nothing but this is the lattice structure. This is a lattice structure of NaCl. So you can imagine the unique character, unique behavior of ionic compound. All the ionic compounds invariably they have same type of internal arrangement. So this is all about the ionic compound.